In this video, we're going to learn a few tips and techniques to make a headlight surround for a pop-up headlight. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to do a one-off. I had a request in the comments about creating the bezel or the headlight surround for a pop-up headlight. Since we just finished the Ferrari series where we actually had a car with pop-up headlights, I thought it would be a good addition to maybe talk about some different tools and techniques that we can use to create that. So what we have here is the front end of a 91 to 95, so the second gen MR2. So this is a car that still has pop-up headlights, and in my opinion, it's the best looking MR2. The first and the third gens just didn't quite have the same lines and looks as this car. So happy to get started modeling this and talk about the process. Before we get started modeling everything, I want to take a second to talk about what I've already done in case you are starting out and you want to kind of backtrack with the things that I've done. So back to the original form body is I created a form body, and of course this is a surface, and I just used the techniques, the same ones that we used for the Ferrari. You can go in and you can modify this and you can add to it. Some important differences or distinctions to this is I used a lot less control in the fender area. And the reason I did that is because this car has a relatively smooth transition from the wheel wells. This time frame, the early 90s, cars were starting to get really smooth. The FDR X7, the 300ZX, 3000 GT, these cars had harder lines in some areas, but they were relatively smooth. So that was kind of fitting for the era. We didn't have any creases or hard edges like we did on the Ferrari to deal with. So as we moved through there, the next thing I did was I created a sketch for where the pop-up headlight brake should be. Now, we talked about this at the end of the Ferrari series, and sometimes you can use the trim tool or you can use the split face tool to actually split bodies up, but sometimes it just doesn't work. So I just went ahead and created some extruded surfaces, and I used those as my split tool. Now, the original reason I did this is because I was intending to use these surfaces as part of the headlight surround, but I sort of abandoned that as I went further in the design. So I decided not to do that, and I ended up creating what we call a skin. So if I hide some of these bodies, what I did was I created basically an offset surface so that I had a body or an offset surface that I could use for the headlight bucket, and then I could delete the face and the body. I ended up splitting the other side using the same method, and then I started by creating a sketch to trim up the hood line. Now, this wasn't strictly required. I just did it for aesthetics. And then I just split the rest of the surfaces, so I had sort of a hood line. So you could pop up or remove the hood using the same techniques by creating an offset surface. Next, I created a thickened version of the headlight. So if we hide the hood, you can see that we actually have something that has some thickness here. And in reality, this is essentially what you would have for the backside plastic piece that covers the headlight. And then I went in and I created a very, very generic pivot point for the headlight to pop up and down. I created a pivot shaft. I converted the headlight bucket in this piece to components. Now, in reality, I could have started with them as components, but because I was basing this off of a form body that was a surface, I really didn't feel the need to start them as components because I was already hacking them from something else. And then I added a rigid group so that they moved as one. I created a new component for the pivot itself. And again, very, very generic, just a rod, only just to represent the movement. I grounded the rod, and then I added a revolute joint, and I have a joint limit for the revolute joint. And then you can see here that, so now the revolute joint has the upper limit, so it can't go any higher than this, and then it stops at the hood. So I did that by setting a joint limit, and you can do that by right-clicking on it and editing the joint limit. In this case, it was about a 28-degree sweep. On the actual car, it actually pops up a bit more. It depends on the car, obviously, but in this case, the original pops up more. But the request was to create a headlight surround for what's considered a rogue headlight kit. So it takes from the original square headlight design to a dual circle headlight design. So that was the request, that was the ask, and that's what we're going to do. So I wasn't too concerned with having it pop up the exact amount. I really just chose that because visually it looked about right for what these rogue kits look like. So now that we understand what has been done, let's talk about what's still in here and sort of what we can do. So I left the what I call the driver's side skin in here, which was an offset copy of the split. And I did that because in a lot of cases, you'll see when these headlights pop up, they'll actually try to match some of the body line and roll up into whatever shape they're doing. So I kept that there in case I needed it as either a trim surface or a reference. And I also have the original passenger side skin and the passenger side thickened headlight, which I didn't really add any joints or components to. I'm only working on this side over here. So that's where we are at. That's the starting point. And now we're going to talk about different ways in which we can sort of make the skin. The first thing that we need to do is we need to have some sort of plane or planar face that we can use to define where the new headlights are going to be. And I'm going to do that with a surface. It could be done with a plane. The surface is helpful because I want to potentially use the surface as part of the rest of it. Now, I will put a disclaimer in here. I haven't modeled this yet. This is the first time that I'm trying it. I've modeled the front of the car and the pop-up headlight part, but I haven't actually attempted at making this bezel. So what we're going through here is my idea of how I would go about it, and hopefully it works, but we're going to just go along for the ride. So we have to think about if we want this new bezel piece to be its own component or if we want it to be part of the driver's side headlight. Now, in reality, it could be a sub-assembly of the driver's side headlight pop-up piece and the pivot and all that stuff. So what I'm going to do is I'm going to make a new component, and I'm going to call this new component DS for driver's side headlight bezel. And that new component, I'm instantly going to go back to the top level and unactivate. And I'm going to make one more component. And this new component is going to be DS headlight assembly. And the reason I'm doing this is because I'm going to restructure the browser a bit. I'm going to go ahead and reactivate the top. And even though we're talking about design techniques for modeling the bezel, we're going to get into some other basic assembly stuff as well. The reason that I want to do this is because it's going to produce a few problems, and I want to make sure we understand why those problems arise and what we can do to fix them potentially. So now we have this assembly, DS headlight assembly, all the work that we've done before. We've got these components here. We've got a joint that is limiting it. We've got rigid groups and so on. But now I want to put the driver's side headlight, the pivot, not this main pivot. I'm going to leave that as sort of part of the top level. This bezel, and I'm holding down the control key when I do this. I'm going to put those three, and I'm just going to drag them into the headlight assembly. The icon changes. Now this is a sub-assembly. And if I try to move this around, it's no longer joined together. And the reason it's no longer joined together is because our joints were at the top level, and now we have this entire DS assembly, and all the stuff underneath it needs to be a rigid group. And what happens is when we create these original rigid groups and we sort of create these joints, these as-built or these regular joints, they are referencing a coordinate system. And they're referencing a coordinate system for things like the DS headlight. And what happens when we create a subassembly is we're introducing a completely new origin. And while it might be the same origin or the location might be the same, we now need to make some sort of relationship between this entire assembly and all the things that are inside of it. So what I'm going to do is I'm going to try to create another rigid group, and sometimes Fusion will actually give me a warning. And I'm going to select create a rigid group with the DS assembly headlight and make sure that I have include child components checked and say okay. Now if we flip this up and down, you can see it works fine. So if you get into the process of setting up a file like this where you have the joints, you have the rigid groups, and then you introduce a new assembly or a subassembly and things break, it's probably because of this extra coordinate system that you introduced. Fusion understands the joints and the relationships, but then you're sort of adding this extra element of these components can move in relation to this origin. And then this origin, this group of components can move in relationship to this origin. So keep that in mind whenever you're modeling in Fusion 360, the nuances there. It's always better to create components from scratch and start that way. Again, I didn't do it here because I had a form body as my starting point. I could have gone back and made a component, but again, this is a good thing to understand. So I'm not worried about it. Now that we fix this, let's go ahead and do a quick save. We don't want to lose any of the stuff that we've done. We've put in the work. We want to keep it. All right. So the next thing that we want to do is we're going to activate the headlight bezel, the DS headlight bezel, the new component we created, which is currently empty. No sketches, there's no bodies, there's nothing other than its origin. And again, it's the same origin as everything else. What I want to do now that this is activated is I'm going to create a new sketch, and I'm going to do this on the top plane. The reason that I'm going to do this on the top plane is because I need to create the plane that my headlights are going to be on. So we're going to create a line, and I also want to use create, project, include, and project. I'm going to hide the body itself, which is, we can do this entire bodies folder, and I'm going to hide the pivot. I don't really need to see that. I'm going to rotate this around. You might need to zoom back a little bit, rotate it around, noting that it's rotating or pivoting about the origin. I'm going to select that entire bottom face now that we're projecting and say OK. This redoes my grid, so now the grid is including this. And if you are worried about the origin location, you can actually move the entire component so that the origin is based off of something real. This is based off the center of the car. So when I drew this originally, I grabbed some very low-res blueprints offline, but the blueprints themselves were not under Creative Commons, so I deleted them out of the file before I shared it. So that's how I know what the shape of the headlight was and all that stuff, that just the blueprints are gone. So that's why everything is based off of that center point. In reality, when you're modeling a car, that's usually how you do it. You pick the center of the car as the origin, but it doesn't have to be that way. You can put the origin wherever you want. It doesn't matter for what we're doing, because all we're really concerned about is shapes of what we already have, and then some references that are horizontal or vertical. So you will want to make sure that we understand that the projection of this headlight is based off the bottom face of the headlight, but also noting that it's based on the headlight in its up position. That's going to be important because that profile does change. So it's in its up position. We understand exactly what the shape of this thing is, and we're going to design the bezel for that up position. I'm going to grab a line, and this is going to be a horizontal line. And we can decide if we want it to go all the way to the profile or if we just want it to be inside somewhere. Again, I don't really care so much about where it is. I want to make sure that it's horizontal in relationship to my coordinate system. That's how the car was drawn. I'm going to hit escape to get off the line tool. And now I need to decide how wide this thing needs to be and where it needs to be. So this is where we're going to determine the plane of the headlights. Now, in some cases, those will be pretty close to the front. In most cases, they will be back behind some curvature, and then the bezel needs to come out from there. Because that's the challenge, that's what I'm going to do. So we're going to use D on the keyboard. I'm going to set this at an arbitrary value of 175 millimeters. I'm going to put a horizontal distance from this point of 32, only because it looks about right. And then I'm going to either use horizontal or coincident constraint. In this case, I'm going to use coincident because this is something that most people don't know to use on things like this. So coincident for this line and this point. And the reason that works is because it's going to essentially extend the line out until it hits that point. We could have used horizontal here, and that would have worked as well. But I like using that trick, especially if you've got something, sort of at a funky angle. For example, if we had some sort of pattern that we were drawing and we wanted all of these things to point towards the center and horizontal didn't work, you can use coincident, and then you can always have those pointing toward the center. Like if you're designing a rim or something that just has concentricity to it, you want to make sure that those lines point at the center. All right, so now we got this. I'm going to finish the sketch. And from here, I'm going to move into surfaces. We could do a solid body, but it's not really needed yet. So I'm going to do an extrude. I want to go back to my bodies folder. I'm going to expand this and bring the DS skin. That's the driver's side skin. I don't necessarily need it, but what we could do is we could take this line And we could start at this object. So we could start here, and then we can move the extent type up to another object, and we can use the underside of this face. So what we've done is we've created something where we don't have to go back and trim or scale or split. We simply have gone directly from the original, the popped down or the folded down surface, and we've gone to the folded up surface. The great thing about this is it gives us a planar reference, which means that if we select the surface, even though the top and the bottom are not horizontal lines, if we right click, we can create a sketch directly on here. And that's exactly what we're looking for. So we're going to create a sketch, and now we need to represent the headlights. I'm going to use L on the keyboard for line, but you can also come up to create. And I'm going to grab the midpoint on the left side. I don't really need to. And I'm just going to go all the way to the right, making it perpendicular. The only reason I have this here is it's a reference for me just to snap to. And again, I don't really need it. I can select it and make it construction. You can use X on the keyboard. And then I can decide where I want my headlights. If I want a larger headlight here and I want a smaller one, so we can give these dimensions as well. I'm going to use D on the keyboard. Let's say that we're going to make this one 50 millimeters, which is roughly about 2 inches. And let's make this one bigger. Let's make it 75. And if we want to, we can define their position, right? We can give them a 50 millimeter dimension here, and then maybe we want to do 50 from this side as well. Right? So now what we have is the location of the headlights, but we need to get rid of that information. So we either need to split the body or trim it or do something. So I'm going to use the trim tool, and the trim tool is going to be this sketch, and then I need to select where I want to remove. In this case, I'm going to remove the center. The trim tool is one of the only tools that I am aware of that leaves the sketch visible. Most other tools like extrude or revolve are going to make the sketch hidden automatically. So this actually helps us because we want to repeat the process by removing it from there. And then we can go into our sketches folder and we can hide it. So now we have a planar reference. We have a plane where the headlights are going to be. And this reference can now be used to help define a form body or a surface body or whatever we need. So the next thing that we need to consider with this, also I should make a quick side note. I haven't taken into account any tolerances. But what I mean by that is the headlight pop-up face is exactly the size that I split it away from the rest of the body. Now, obviously, there are going to be gaps, and you have to account for those. So, for example, if the headlights were exactly 50 and 75 millimeters, then the circles that we drew need to be a little bit larger. You need to have some flexibility there. But what we can do from here is we can actually do a handful of things. If we have mounting holes on the side of it, so let's say that we were actually building this entire assembly ourselves, we can use tools like Extend, and we can grab this edge, and the type can be perpendicular. And we can simply extend an edge back. I'm going to hold down the Control key on a PC, and notice that when I do that, the inputs are not connected and it doesn't like it. So we're going to have to do those individually if we are trying to build it this way. But you can see that now we have this sort of planar reference. This is going to be a flat plane that we can sketch on. We can put a bolt hole location, and it's completely perpendicular to the face of the lights. So whenever we're building some sort of assembly or a mount, this type of tool, such as Extend, can be extremely helpful. Then we can come back with Trim, and the Trim tool can be the original pop-up portion, and I can rotate this around and remove that. We can do the same thing if we repeat Trim and use the inside face of our solid body. So even though it's a solid, we can use that as our Trim tool. And now we've trimmed that planar reference. And again, we can sketch on this. We can create a sketch. We can put a bolt hole location. Let's say that we have an 8 millimeter bolt hole. I'm not going to worry about dimensioning it, but you certainly could, and you should, obviously, if you're trying to replicate or build something. But now we have that whole reference. So if this was going to be a mounting post, we could extrude it as a solid. Or if it was going to be a bolt hole location, we could just use Trim and cut it away from our surface. So that's a Trim tool, get rid of that. And now we have a bolt hole location. So that is something that we can do. And we should always be mindful of the fact that tools like Extend are going to stitch or knit those bodies together automatically. So you can see there's a 2 here, which means it's got 2 faces, 1 and 2, but it's one single body. So that entire thing, even though it's selected now, that entire thing is one solid body. So keep in mind that when you use tools like extend, it is actually extending the surface. Even though it's perpendicular, it's extending that back. Okay, one last tip for you on this, and then we'll move on and we'll start to actually create some cool geometry. If you are going to do something like fillet this corner, you should fillet this before you trim it. And the reason for that is because when you create a fillet on a corner like this, if we go to modify and fillet and we start to pull this in, there is not a guarantee that it's going to perfectly match those trimmed surfaces. In this case, it's probably going to be fine because the trimmed surfaces are single faces. They're not very complex, but that is not always the case. So it's a good idea for you to build that geometry first, add the fillets, add the detail that you want, and then go back and trim it afterwards. Again, it's not always required. In this case, we have one big, fairly broad surface and another one here, so it's actually going to do pretty well, but it's not guaranteed, so keep that in mind. Okay, so now that we're here, this is where we've got sort of the pop-up headlight. If I try to move this up and down, you can see that that goes with it. If we rotate it from the side, you can see that it rotates with it. And that's because it is a component that we created, even though we didn't have any geometry. It was a component we created in the headlight subassembly, and it all is created as a rigid group, which means everything that we do in this bezel, even though it's a surface, it's going to move with the solid body. It's going to move and respect all of the other joints that we've applied. So now that we understand that it's going to move, we've got everything in place, we have our planar reference, we have our headlights. Now, how do we design a bezel? All right, so this can be done several different ways, and part of it's going to depend on what you want it to look like. So the first approach that we're going to take, and I know we're already 20 minutes plus into this, it's only going to be a single video, so if this is interesting to you, then just hang on, we're going to get there. But we're going to take the approach first doing this with some surfaces, and then we're going to try to do it with some form tools. So we're gonna have at least another 10 or maybe 20 minutes in. So keep that in mind. We're gonna get there. So from here, we're gonna create another sketch. We're going to use the top plane again. And we actually could use a sketch that we already have, but just in case you are going to be using different geometry, I think it's important that we use a new sketch. So I'm going to hide the hood. I don't really need to see it. I don't really need to see the passenger side body. And I don't really need to see the driver's side skin at this point in time. What I need to do is I need to rotate this around. And I'm going to use my mouse wheel. So as I'm holding down the shift key, that's how I rotate, shift in the middle mouse wheel. If you click the middle mouse wheel, you're going to reset the pivot point. So that's especially helpful on something like this where the origin is way away from our object. It's going to help us rotate this a little bit easier. So I got that face selected. P on the keyboard or create, project, include, and project will allow us to project that entire face back down to the top plane. So from here, what we're going to do is we're going to extrude this up as a surface. I don't actually need to worry about the back. All I need to worry about is the two sides in the front. So if we want, we can select these two edges holding down Control or Shift, or if you're on a Mac, you can use Command. And we can convert those to construction either by using this option here or hitting X on the keyboard. I'm going to finish the sketch, and now I'm going to bring back my driver's side hood skin. We're going to use extrude again, the same thing that we did to create the front face for our headlights. We're going to extrude this. We are going to go from an object, which is our DS headlight skin. We're going to rotate again. If you want to click the middle mouse wheel, reset that pivot. And we're going to go to an object. And here we're going to go to here. Notice that nothing is being shown right now, and it's failing. The reason that it's failing is because it's an exact match for this shape, but it's not an exact match for this shape. We didn't offset it in at all. Now, in reality, it wouldn't match the edge perfectly. So what we can do is we can either offset this curve in, or we can come up with a solution by extending the headlight skin. Either option is going to be fine. If you want to use the option of extending the headlight skin to trim it, then we just need to simply come from the profile plane all the way up, or we need to extend everything that we're doing here. So because it's going to be problematic and because time is of interest to us, I'm going to go ahead and edit this sketch, keeping in mind that I already created a construction version on the back. And from this view, you can actually see what we're working with. We can see the headlight piece here, but we can also see the headlight skin. So you can see right here, our edges extend past where we want them to, and that's part of the problem that we're running into. We're going to push forward, and I'm going to use offset, which is in modify offset. I'm going to select this, and I'm going to bring it in, and we need to decide how much. I'm going to say -5 millimeters and say OK. When we do that, we do want to make sure that we're not extending past this back edge, and you can see that we are. We're going to try it anyways, but just note that we do see that. So once again, we're going to extrude. This time we want to select the inside chain. We're going to try to go from an object one more time. It's probably not going to work, but we'll try it. And then we're going to try to go to an object. Again, middle mouse wheel, click, and instead of that, I want to go to this inside face. Notice again, it's giving us problems. It's giving us an option where we can either use the adjacent faces or the selected faces. If you use the selected faces, you'll notice the icon shows it stopping. Adjacent faces will actually carry those faces on. The starting point is causing a problem. So if we try profile plane, you can see that it's still not working. So let's go ahead and let's just do distance. Let's bring this past everything, and then let's see if we can work with it like that. I'm going to say OK. And now we need to trim this. So I'm going to use the trim. I'm going to rotate this around. My trim tool is going to be the inside face, and then the trim is going to be this outside section, and I'm going to say OK. So notice it allowed me to trim that. Let's try that again. Right click, repeat trim. This is my trim surface. I want to get rid of everything below it. All right, so you can see that that worked. That allowed me to create that bezel. It's still a surface body. We haven't thickened it or done anything with it yet. It's still a surface. So now we need to figure out how to go between this to our headlight, which is set pretty far back, honestly. We could bring the headlight up quite a bit more if we wanted to, but let's just see what we can do. So the next thing that I want to do is I want to find the sketch that I used for my headlight. So these are the circles that I drew. Next, I'm going to rotate this around, double click the mouse wheel to center, but again, it's the entire car, so we need to zoom in. I need to decide if I want to sketch on the same face that I used for my headlight, or if I just want to grab the front plane. In this case, I'm going to sketch on the same one that I used for the headlight pivot, but I want to temporarily hide that sketch, and I'm just going to right click on this face and create sketch. Now what that does is it automatically projects everything for us. So if I hide that body and I select this face, you can see the profile already has those edges for me, so I don't even need to show that other sketch. What I do want to do is show the body that we're interested in sketching on. So in reality, what we want to do is we want to project these circles forward to give us something to loft to. Now, I'm not actually sketching on this surface, so I can't really project them to the surface, at least not yet. So what I need to do is I need to draw the sizes that I need. So using my circle tool, I'm going to find the center of that circle, and I want to draw a little bit larger. In this case, I'm going to go to 85 millimeters. I'm going to do the same thing over here. This one was 50, and I'm going to go to 60 millimeters. From here, I want to bring back the body I'm interested in, and I'm going to finish sketch. Now I'm going to trim. Using that as my trim tool, get rid of that section. And again, right-click marking menu. If you get really good at the marking menu, what you can do is actually hold the mouse button, the right mouse button down really quick and just drag up, and it'll go right to that tool. So I do it slowly just so that we can see what's going on, but you can get that done pretty quickly. Okay, let's bring all the bodies back. Now we have the planar face reference for the headlight, and now we have this extended piece here. Now, what we want to do is we want to connect those. Depending on the headlights, obviously these two are pretty far apart, but depending on the headlights, the headlight angle, you could do this a couple different ways. We could simply come in and loft from this edge to this one and just leave it straight. Now, this is great, especially if you can match the angle of the headlight, maybe pull this face a little bit closer. That's a good option. Another way that we can do this is we can determine how we want to enter and exit these curves. So on the front end, where it's visible, we might want to have tangency or curvature. I'm going to select tangency, and notice that it gets a bit crazy. The reason it gets a bit crazy is right now, it's just the profile is not liking that transition because it's creating what's called self-intersecting geometry. If we view this from the front, all of these little angles here, these edges are self-intersecting. And if we rotate this around, sometimes we can get these points to a location where it's okay. You can see here we have a preview, but it's creating self-intersecting geometry. And another thing that we want to note is that this number here, this tangency weight, is controlling how much the tangency of this edge matters. So if I say 0.5 and reduce that tangency, it might help. The back edge, profile 1, right now is connected. And we don't really want to have that back edge tangent because of this plane, unless we extruded that edge back more like an axis for where the headlight is. So you can see that this one is causing problems. Let's try curvature and just see if it gives us any better solution. But you can see that the loft is still not being created. If we rotate this around, it is just not liking that transition. And the reason it's not liking that transition is because it really doesn't know, it doesn't have enough room to get the transition how it's trying to. So the way that we could fix this if we needed that curvature or that smooth edge on the front is we could come back and we could create what's called a guide rail. And that guide rail will help us drive the shape a bit more. Because the main intention of this is really to get to the more complicated one using forms, I'm not going to go through that process. Instead, what we could do is we could stitch these together. So for example, we can select stitch these two together, and then we can add a fillet, modify fillet, select this edge, and then we can round it off and create it that way. You'll notice that it's cutting into this edge here, so I'm not going to do it just yet. But again, that is an option. Let's go ahead while we're here. Let's just loft from this one to this one. Again, those points are important, and I'm going to stitch these two together. These could all be done at the same time. And now what we've created is a very basic bezel. We could take this surface body, we could thicken it. In this case, I'm just going to say 2 millimeters. It can be thickened outward or inward. We could just pick which side we want. In this case, to go the other direction, I would say -2 millimeters to thicken it inward. And now we have a solid body. So if we look at this, you can see that we have a solid body. It didn't bring those stitched sections in. And if it didn't, we can undo. We can take a look at this entire body and we can try to thicken the entire body. What we did was we selected a face. And when we select a face, sometimes it doesn't bring those along with it. Now you can see that the solid body does include those. We could add fillets to it. We could add details like mounting bosses and cut holes in it. But now we have a thin bezel, and the thin bezel matches the bottom shape of the car when it's open, and it also all moves with it. So it closes and it opens, and now we have that bezel. All right, I know we're pretty far in. We are 30 minutes in. Let's go and let's move on to creating a form body. Let's try to create a form body of the same thing. I'm going to do the form body in this headlight bezel component so that they're all together. It doesn't necessarily have to be done that way, but let's do a quick save before we move on. So back on the solid menu, we're going to select create form. And create form, in this case, we have to be kind of careful how we do it. We can do this with extrudes and we can use some of the primitives. I'm going to start with a plane, and I'm going to create the plane just on the front. I'm going to go to a front view, and I'm just going to create just a little bit of a rectangle. For the width faces, I'm going to set this to 1. And for the length faces, I'm going to set this to 1. You can see that it doesn't really like that. We can move this up and down. It really wants to have 2. Let's go ahead and let's put 2 in there, and that'll be okay for what we're doing. The reason I wanted 1 is because I didn't want to have too much control. So at this point, I'm just going to select those bottom ones and hit delete. So now I just have these 2 faces here, 2 edges on top, 3 vertices to control, and then this sort of vertical edge below it. So I'm going to box select everything, go to modify, edit form. I'm going to put it up in roughly the right spot here, probably rotate it just a little bit. Then from the top view, I need to make sure that it's in the right spot and need to bring it forward. So grab the arrow, bring it forward, and then we need to figure out where we're going to put this. So I'm going to bring it all the way forward. I'm going to box select. Remember, I'm grabbing both of those vertices, and I'll do the same thing here, bring it back. I am also going to go into box display mode, which is Alt and the number 1. We can also go to selection options, and display mode is here as well, so you can do that directly inside of edit form. All right. So I really want to cover just a few tips here. So we're going to hide the hood surface body. We're left with the DS skin, and we're left with the solid body up top and also where our headlights are. So the first thing that I want to do is I want to go to modify and note that we have a couple tools. We have match and we have pull. When we've looked at these in other series, I did one creating a spoiler on a model that was a surface body, and we converted it to mesh, and we kind of looked at that. If you haven't seen that, you can go ahead and watch that video, but we're going to talk about these two here. When we look at pull, you can see that there's a target, auto option, and selected targets. When we do selected targets, I can select a surface or a face, and it's going to automatically grab the border. When I select vertices, it's going to push them up. And one thing you'll note is it's set to surface points right now, so the control points don't look like they're touching. But if we were to go into smooth display mode, which again is Alt and the number 3, then smooth display, those vertices are actually touching those edges. We can also change it to control points, which means that the box display will touch. In this case, because we're talking about the edge of a surface, it doesn't really matter. Either of those is going to give the same result. But just note what it's doing is it's pushing those vertices to try to touch that surface. Now, if we change the target and we select the edge, you'll notice that the result is a bit different. Instead of pushing it up and trying to touch the surface, those points are now being pushed to that edge. So that's the pull tool. If we take a look at the other tool that we have in here called match, now this match tool is looking at the sketch or edges of a surface or solid body. So they're very similar, except for the pull tool works on mesh bodies. So if we take this edge, so you notice that it's not allowing us to select a vertice. We take those edges and we're trying to match this edge. It gets a little crazy. We have to turn off tangent and we have to try to select a specific edge. But you can see here it took the entire edge of what we had and it's trying to match the edge that we selected. So this is one of those cases where the match tool is probably going to give us a better option than the pull tool, unless you really need a lot of control of selecting those vertices. Also notice that there are some options. We can determine some tolerances. We can use this fall off option, which allows us to control how much of the rest of the shape is influenced. It's not going to change anything for us because we don't have any vertices in the middle. We did that on purpose. So we're going to just go ahead and say, okay. I'm going to double click this upper edge and I'm going to bring it down in a way. And then I'm going to use that same match tool. I'm going to select these edges. And again, tangent chain is turned off because we don't want it to completely go kind of crazy. But note that we can select more if we want to. So this is the basics. This is the starting point of that cage, right? So hopefully that you can see just looking at this that we could divide this up more and have it wrap around. And let's go ahead and do that. Again, this video unfortunately is going to go on for a bit, but if this is something you're trying to do, then hopefully it's interesting. So let's pull that up. Let's say okay. Also note, when we go back to box display, you can see what the box display looks like. Smooth display looks pretty good. We don't need a lot of control in order to match this. What I'm going to do is I'm going to take this back edge, modify edit form. I'm going to go to the right view, and I'm going to use Alt and Control. And the reason I'm doing that is because I have a sharp corner there. I'm going to use Alt and Control and bring that back. I'm going to take this edge, just using Alt, and bring this one back. And I'm going to say okay. So let's see how this works and how it handles the corner here. So I'm going to rotate this a little bit, zoom in. Let's go to Modify, all the way down to Match. And my T-spline edges are going to be all the ones on the top. My match edges, again, tangent chain is turned off, and I want to select these 3 edges. I'm going to say OK. I'm going to repeat the process. So again, we're going to select all of the edges that we're interested in. Match edges, tangent chain is turned off because we don't want to go all the way around. And now you can see that it's pretty close. It's pretty close, but there is a problem back here. So you can see that in reality, we might want to split this thing up, potentially move those around, but you can see that we do have a result. And part of the problem is the surface on the bottom crosses the surface on the top just by the nature of the headlight pivot. So we need to do some manual work here. I'm going to take this and I'm just going to pull this forward a bit. We're not going to match that shape anymore, but again, hopefully you can see that. And actually, you know what? Let's cancel that. Let's do this a little bit differently. Because we are so interested in matching that, let's use insert point. And let's go from here to here. And then select this face and delete it. We'll do the same thing on the other side. Again, middle mouse button while you're rotating will help you reset that pivot. And I'm going to go to insert point. And it's not really giving me the same graphical preview, but let's go ahead and delete that. So we lost a little bit of the shape, but hopefully you can see with a little bit more prep work. As I mentioned, I didn't pre-model this, so you're kind of seeing this. Happen on the fly. So hopefully you can see with maybe a little bit more thought put into this underlying surface. Maybe if we trimmed it, it would have been a lot cleaner. We can still fix this by using modify and pull. And we can take this vertice and maybe this vertice. We can take it up to our selected target, which is this face, and just pull them up. We can repeat that process using the lower vertices, and the target is going to be this bottom surface. And that gets us back into matching that shape using both of those tools. We have a crease on this edge. You can see that it's kind of rolling in a little bit. So if we want to, we can make some manual edits to this. We can come in and modify and maybe pull this corner back a little bit. And it is hurting us because we have so little control on this. So we might want to add another edge in here. Modify, insert edge right in the middle. And then go back to modify, and we're going to use match. This time we're just going to select these 2, and then the match edge will be that right there. And now you can see it messes everything out. Also, let's go ahead and hit cancel. We'll use pull for this one. So we'll pull these 2 vertices, and the selection is going to be this edge. It'll just pull those back. We'll say okay. As you can see, it's starting to get a little bit out of control. So I'm going to use Control Z. And we're just going to have to roll with that, unfortunately. I could spend a lot more time and sort of tweak this to get it a little bit better, but I'm just going to get it close, and hopefully you can see or understand what we're doing in order to get that. The next important thing that we need to do is we need to figure out how to transition from this to the headlight itself, right? So we need to be able to extrude something back, and that's probably the next biggest challenge. So let's go ahead and tackle that. And to do that, we're going to need some more divisions. So I'm going to select this face. I'm going to go in, I'm going to modify and subdivide it. When we subdivide it, you can see that it's starting to mess up our curvature again. We're going to do an exact, which will keep it in the right location. We can also specify if we want to increase the number of faces so that we have something that we can delete, then we can do that. We're going to say, okay, I'm going to take this and I need to get rid of it. Now, ideally what we would do is we would use something like bridge, and we would, bridge back to that edge. We don't have that option, unfortunately. So I'm going to hit delete, and notice that the edge it gives me is round. It's automatically trying to make it round. I'm going to double click on that, go to modify, edit form, hold down Alt and pull this back. I'm going to let it go once I'm right about where the headlight is, and I'm going to say okay. Hopefully you can already see where we're going, but we're going to use our tools, right? So we're going to use match. I'm going to double click that to grab the entire edge. Then I'm going to select this edge, and you can see that we're matching the headlight shape. We're going to say okay. And if we want to keep this as is, I can double click on it. I can go to modify, and I can go down to freeze. Freeze will ensure that that edge doesn't move, and if it does, it'll give us a warning. So now I can take these edges. I'm going to hold down Control or Command if you're on a Mac. Go to Modify, view this from the front. Let's find where it is. View this from the front and scale them out. So I'm scaling them out, maybe moving it a little bit so that I'm better in line with the headlight. And you can see that we're starting to create this shape. Now, if you want more control, obviously you can add more edges, more subdivides, or just insert points wherever you need the control. If you want this to be creased, then we can do that as well. We can select it, again, using Control or Command, grab these edges, and we'll go to Modify and Crease. Now, if we crease it, it's obviously going to change this, but now we can come in and add things like a bevel. So if we want a beveled edge, we're going to put it relatively close, 0.05, and I'm going to say 2 segments and say OK. Notice that it's telling me that it's going to unfreeze some of our regions. It's affecting the curvature too much and that it's causing it to affect where we wanted to fix it. So I'm going to say cancel. I'm going to double click this edge and I'm going to insert another edge. Notice that it's trying to put it on the front. That's not where I want it. Sometimes if we use a positive value here, let's say 0.5, it will allow us to switch the direction. But you can see that it's automatically changing it to the opposite side. And there's not a good way that I know of. If you guys have run across this before and know of a good way to get it to be on the correct side, and please let me know. I'm going to do it by just double clicking the back and putting it in here and saying OK. And now what this does is it puts sort of an edge between our frozen edge and what we want to modify. So if we go back to freeze, this edge may have been unfrozen, so we want to make sure that it's frozen. And now for this bevel, we can come in and uncrease it. I want to uncrease this one as well. I'm going to work my way all the way around. And we don't need to use bevel to add the crease necessarily, or I should say we don't need crease to add the bevel, but sometimes it helps to have that sharp edge, especially when you're trying to create some sort of shape on the front. So now you can see that we've got sort of a round headlight opening and we're transitioning to the shape. This is likely going to cause us problems when we go to turn this into a surface or a solid body. So I'm going to make some adjustments. I'm going to grab that. I'm going to use slide. And I'm going to try to slide that backwards. And this is another tool that sometimes can be a little finicky. You might need to just try it a couple times. And then you can see here, if we go to box display, these edges are really close. So I'm going to use modify and slide edge in box display. Maybe help me see a little bit better. Push that back just a little bit and go back to smooth display. So that looks better. We're now getting a pretty good result. All right, so at this point, you probably you need to think about a couple things before you get into forms. When we're inside of forms, we need to think about how much control we need, what kind of shape are we trying to match, and likely it's a good idea for you to build that surface or solid body that you're trying to match before you come into forms. There are, inherently there are some things that we can do to manipulate the shape. If you want it to roll down so that it sort of matches the curve of the car, that's a little bit more of a challenge. What we need to do is we need to match this edge and then we need to freeze it and add more control. So, so again, if we use pull and we try to bring that vertex over to this edge, and then we want to freeze this edge, for example, in order to prevent that from moving, I'm going to need to add a lot more control in here. So I need to come in and I need to subdivide, maybe subdivide these faces. I'm using exact, which means that this edge will stay. And if we don't have enough control, we can always come in and use things like insert point. So we'll come in, come back for insert point. Notice that it's trying to unfreeze. I'm gonna hit cancel. It left that because it doesn't want to unfreeze it, but we'll still be able to play with this a little bit. So this blue edge and these two edges are frozen, which means that I can use modify edit form and I can bring this in a little bit. Not the best, but it can show you how we can maybe manipulate some of this geometry. If I bring this edge in and I try to move it, you can see that the frozen edge stays. One thing that we should be mindful of is that we don't have great control over the tangency at that edge. We do have the ability to control it, but we don't have great control. There are a few ways that we can do it. If we go to a vertex selection, for example, we can grab these handles and we can do that manually by moving them down. Again, it's not great because it's not automatic in nature. So it's not giving us that level of control based on a surface selection, but we can still do it. So when you look at things like headlight bezels, they're not perfect. They have lips and edges and different things on them that that affect the shape of them. So we can come in and we can add that level of control by grabbing things like this and sort of pulling them back and getting that shape. So you can do a lot of that work. And then once you're happy with the shape, then you can go into tools like pull or match, and you can pull them out to the edge. So that'll get you a little bit closer to matching something cosmetically, like if we were to look at the hood of the car and look at this from the side, not super appealing. You might want to take a lot of this and sort of move it back. And let's go ahead and use the multi-selection. So we might want to grab, let's grab this edge here, pull that one back. All right, so that looks a little bit better than just having a big block face here. But again, it takes a lot of time to get something that's cosmetically pleasing using this methodology. It's a lot easier for us to come in and use the surface method, which we turn into a solid body relatively easily. To use this method, we have a lot more control over manufacturable outcomes. It's probably the best way to put it. Whereas when we use the surface, you can see that it's going to be a lot of pushing and pulling. You're going to have to come in, you're going to have to get the rough shape and control you want, then use tools like match or pull to match a shape, in this case, the closed version of the headlight bezel, and do that. If I were going to design this, I would likely just do it with surfaces because the surfaces will give me that level of control that I'm really looking for. And I'm going to give you one more example. Again, I know that this video has gone on pretty long. We're almost at an hour, but a lot of things are packed in here. So let's look at one more thing with surfacing that could be helpful. So we're going to go back to the loft tool again. And I'm going to loft between this edge and this edge. So lofting between those edges gave us the face that we were looking for. But now I'm going to go for profile 1, I'm going to say tangent. Now you can see that the tangency right now, let's flip it the other way. Let's just pull that handle back. The tangency is now a much better match for the actual hood. Right, so it's looking at the curvature surrounding it, and on the upper edge, you can see what's actually happening is that tangency. We haven't done any tangency on the top, but we certainly could come back and make that one tangent. We could pull that one in, and you can see that we're getting a more organic looking shape. Now, if you really want to focus on what this thing looks like at the front, you can take these little white dots and you can pull them around. Now, there will be situations where this thing isn't going to rebuild, so you are going to have to take some time playing with this. Sometimes it doesn't really like it when tangency is used. You might need to go back to connected to try to get that to work. Sometimes it just ends up flipping. And when I say flipping, what happens is the dots are representing the start and the end profile. And sometimes when they flip, it doesn't like it. But you can do this by breaking up the surface by splitting it with sketches. So if you want to create some vertical lines and split, a couple different positions for the surface, then you can do that. You can see here, it really doesn't like us changing that input in some cases. But again, tangency or curvature, we can use the arrow on the screen to flip the direction. And that gives us something that looks pretty good. When we look at this shape and we want to figure out how to carry the rest of it back, Then we can use tools like Loft. We can use tools like Patch if we've got a closed boundary. And Patch is a good one to use because of the continuity and the shape that gets created is pretty nice. But we can also continue to use things like Loft. So I can select this edge here and loft between them. And then for a rail, I can use my existing surface that we created. It might be hard to see, but I can grab that existing surface to help control that shape. So on the bottom side, obviously this crosses over, so we don't like that. Um, and again, it's for some reason it's having some issue with this shape, but in some cases it works just fine. In other cases, it might be problematic. But you can see here that if we were to split the original surface up, then we wouldn't necessarily have that problem. But we use the guide rail. At the guide rail, we can say that we want to carry the tangency back. At profile 1, we want to continue to be tangent on the bottom. It's not working because it crosses back here. But again, that's usually not a problem. I don't really know why it is on this model for some reason. But just keep in mind that these tools will give you probably much cleaner surfaces, and you are 100% connected and controlling it at the edges. So this is going to be a much cleaner and much better result than using those form tools. And of course, we could come back and we could trim this. The self-intersection is not great, but again, it's really based on the fact that the selections that we're using cross, so they're going to cross there. But you can see that that surface right there is pretty good. I mean, that looks pretty good. When you look at that from the side, if you connected the headlight portion of that, that's going to be a really good result. So I know we're an hour in. That was quite a lot of work. I'm still going to put this entire video up. I might make a shorter one just to show maybe a quick process of how to do this, but hopefully that answered enough questions and gives you enough idea of how you can build this if this is what you are trying to do. Again, my suggestion is to use Loft and to use surface tools. It's going to give you a much better result. And remember that these are all still connected and they all are still going to move with the rest of the body. So we still have that headlight popping up and down. Sometimes it can be hard. I still have the surface there, so I have to select that body. But you can see that pops up. It looks pretty good. Pops down and so on. So again, hopefully that was enough. Hopefully that gave you the information that you needed to help create this thing. And if you have any questions, obviously let me know. I'd love to hear how this process goes, which route you decided to take, which method you used. And yeah, so thanks for watching and hope to see you in the next one.